So, oxyions. If we look at the periodic table, the most common oxyions are all grouped together. That's supposed to be a P. So these elements here all make oxyions. If we look at them, we see borate, 3 negative. We see carbonate, 2 negative. We see NO3. I'm writing this, I'm probably going to run out of room. So our oxyions for the 8. We'll see this square here, which includes phosphorus and sulfur, have 4. The other ones have 3. We do have some transition metals, but they are less common. And to figure out the charge, so this is in group 5, so we have a plus 5. No, that's in group 3. And then we have 3 oxygens, so that gives us a minus 6. So we get a net charge of minus 3. This is in group 4, so we have a plus 4 charge and negative 6 for the 3 oxygen. So we get a net charge of negative 2. Same thing for nitrogen. Nitrogen is going to be in the 5th group, so plus 5 with the minus 6, giving us a net charge of negative 1. These 4, same thing, except for they have 4 oxygens, so they have a negative 8 charge here. This would have plus 5 here, so they get a total charge of negative 3. These are in the 6th group, so plus 6 with the negative 8, so they get a charge of negative 2. These are halogens. The halogens is going to be plus 7, but we subtract 2. And then the 6 oxygen gives us negative 6, so that's plus 5, and negative 6 gives us a negative 1 charge on those. So we can add up all the charges to get the charge. You just need to remember that phosphorus and sulfur, the square, gives us the only ones that have 4. All the other ones will have 3. So it's a nice way to remember the formula. And charge of each one. It's the group number is going to be the charge of the cation. So the cation's charge is equal to the group number. Unless it's a halogen. As they have group number minus 2. Or 5. And then if it's the base 1 is just going to end in, so it's going to be root 8. If it's plus 1 oxygen atom, then it's going to be per root 8. If it's minus 1 oxygen, then it's going to be root 8. And then if it's minus 2 oxygen atoms, then it's going to be hypo root 8. So once you get the charge and the formula for the 8 version, you can go to the other ones. So for example, nitrate is going to be NO3, and it's going to have a charge of negative. So to go to per nitrate, we keep the charge and add an oxygen. To go to nitrite, we drop an oxygen. And to go from hypo nitrite, we're going to drop 2 oxygens from the 8 version. Does this make sense? So the one we haven't covered is the hydrogen polyatomics. So I forgot to mention this. You don't really need to know this, but for reference, the naming scheme we're using is IUPAC, which stands for the International Union of Pure and Applied Chemistry. They kind of set the standards across the world, and they came up with this naming scheme. The preferred way of writing this name is hydrogen carbonate. However, if you ever look at a bottle, they use the old name, bicarbonate. If you see bi attached to an oxyion name, the bi means hydrogen is attached to it. In other cases, it means 2. So if it has an 8 ending or an I ending and you see bi, this bi indicates it has hydrogen attached. So what would be the formula for sodium hydrogen carbonate, often just called sodium bicarbonate? So, what is carbonate's formula? CO3, and what's the charge? Negative. So then would it just be NaHCO3 negative? I'm trying to make sure that the hydrogen doesn't change the charge. So when we add the hydrogen, yeah, so that's what was confusing me. What's the charge on carbonate? So carbon has how many? What group number is carbon? 4. So we have thus 3 times a -2, which is -6. So this would be -2. When you add hydrogen, what charge does hydrogen normally have by itself when it's an ion? Hydrogen normally becomes what ion? H plus. It can be H negative, but it's usually H plus. So when I have carbonate, so this is carbonate, when it becomes hydrogen carbonate or bicarbonate, the H charge is going to reduce this to a negative. So bicarbonate or hydrogen carbonate, HCO3 would have a negative charge. Sodium would have a positive charge, so it's NaHCO3. That's the full formula. So let's do sodium bisulfite. Again, the recommended way according to IUPAC of saying this should be sodium hydrogen sulfite. So let's start with just sulfite. So it's going to be sulfur. This is one of our exceptions. It has 4 oxygens. So this will be sulfate. So the 4 oxygens gives us a total -8 charge. The sulfur, which is in group 6, right? Gives us a +6. So 6 minus 8 gives us a total charge of -2. So this is the correct formula for the sulfate. When it becomes sulfite, we're going to remove an oxygen, but keep the charge. So this is sulfite. And when we add a hydrogen to it, it's going to reduce it's going to add a positive charge. So -2 plus 1 gives us a negative charge. And so it's...
I would hate to wait, do you have a yardstick I can borrow?
What do you need it for?
We're doing a project and I need to get my line straight.
Bring it back.
I will. Thank you.
So bisulfite is HSO3 negative. So sodium hydrogen sulfite or sodium bisulfite would thus have the formula. So hydrogen sulfite is HSO3 negative. Sodium is Na plus. And so we get a formula of NaHSO3. And remember, final answers don't have any charges on the compound. You won't ever see this, but I'll give you, let's see if I can look up and see if it has any alternative names. Let's see if we can guess this one. I'm not going to give it on the test or anything, but what do you think the formula for sodium dihydrogen arsenate would be? So let's break this apart. What's arsenate's formula? So arsenate is AsO4. So it's in our little square with phosphorus and sulfur. So it is an O4. And it's in group 5, so this gets a plus 5. And there is 4 negative 2 charges. So that gives us negative 8 here and plus 5 here. What are these combined together? Negative 3. What does dihydrogen tell us? There is 2 of them. So dihydrogen arsenate would have 2 hydrogen attached to the AsO4. So what would the new charge be here?
Negative.
Just negative. So the 2 hydrogen are going to contribute a plus 2. This would have been negative 3. So plus 2 and negative 3 gives us a net charge of negative. So dihydrogen arsenate is H2 AsO4 negative mixed with a sodium plus. These combine to get us the formula NaH2AsO4. Let's see, what else do we need to cover? So when is the ending IDE used? It's
Negative charge ion.
It's used when the anion is only a single atom or a single element. Not atom, because there can be more than one of the same type. When is IC used? And this one has two choices. So, used for an acid. And what'd you say? 8? Oh, wait, yeah, never mind. You're right. When an acid includes an 8 anion, or an anion ending in 8. Because we go opposite. That has an I, so this would not have an I. R is used with the prefix hydro for binary acids. So, for example, hydrobromic acid, which is HBr, and this would be bromic acid, which formula would be HBrO3. And then 8 and 8 are for the oxy anions. By the way, what does the word nitride refer to? Exactly. N3 negative. So it just refers to the anion of nitrogen. So nitrogen, so in other words, a nitrogen ion, more specifically anion, but uh, so let's see. Some definitions. Monatomic ion. First of what?
That's 1 type of metal.
So one an ion that is only one type of element. Or atom. So a single element ion. Versus polyatomic. By the way, there is a spelling with this with the O in there, but it looks weird to me. I prefer the monatomic. So this would be an anion that has at least two different elements. Usually, we would not include H as being a different element in it. This goes back to this case. So for example, see and make sure I'm correct on this. Sodium hydrogen sulfide. I don't think that's a real thing. Could be surprised though. Yeah, its name wouldn't be sodium hydrogen sulfide. You want to take a guess what that would be?
I have no idea.
It prefixes it with hydro. So if you take the ion, so S is -2. If you add a hydrogen to it,
Hydrosulfuric acid.
then it's so this is sulfide. This would be hydrosulfide. So if we look at the other names of it, sodium hydrogen sulfide is an acceptable name. The word hydrogen means you added hydrogen to it. We just don't do it with 8.
Where does sulfhydrate come from?
Hydrate?
Sulfide. That's weird.
That is very weird. I have no clue because hydrate means it has a water molecule attached to it. And there's no oxygen in it. I have no clue how that name comes. I know bisulfide tells you means hydrogen's done. I would have thought this would have been the proper name, but it's not. I'm not gonna give any major trick questions like that. I'm just trying to get y'all to the point where y'all could at least look at chemical formula and give it a name and give its chemical formula. So, what's a cation? It's a positively charged ion. Well, anion is a negatively charged ion. What does binary compound mean? What would binary compound be? It's a compound that contains exactly 2 elements. What about, let me get the spelling correct, ternary? More than 2. Similar to poly.
diatomic sometimes, don't they? If there's just two.
Yeah, di and bi is Latin versus Greek. Oh wait, you're right. What is ternary?
Tertiary consumer is the third one.
Yeah. It's 3. Ternary means it's a compound with 3 elements. But I've been using it to mean polyatomic. A poly compound. Polynary. Hey, on my pen, it must be out ink. Yes. What is an acid? It is a compound that produces hydrogen ions when dissolved in water. What would a base be then? A compound that produces what? Hydroxide.
Is that the lesson Thursday?
Hmm?
Is this the lesson Thursday? The acid and base?
Mm-hmm.
I need to go watch that.
Yeah. So remember, hydroxide is OH negative. Yeah, because you didn't even know about ick. And it reminds me us. OUS. That is for used for acids. Yep. That include an ite anion. So bromous acid would be HBrO2. Important thing about that you need to know about spelling for sulfur and phosphorus. So we have sulfur. When it becomes an ion, it's sulfide. And when it becomes an acid, it's sulfuric. We include the UR. Or sulfurous. Same thing with phosphorus. Phosphorus includes the OR in the IKE and OUS versions, but omits it in IDE. So what would so sulfuric acid versus sulfurous acid versus hydrosulfuric. And remember, this one is an exception. Not really exception, you can still call it that. But its preferred name isn't hydrosulfuric acid. So the I tells us we're going to have the ion sulfate. The OUS, so the I without the hydro tells us it's sulfate. The OUS tells us it's sulfite. And the hydro with the ic tells us this is going to be sulfide. So sulfate is SO4. And that has a 6, that's an 8, so that has a 2 charge. This would be SO3 with 2 charge. And sulfur is 2 charge. Hydrogen, it's going to be a plus, hydrogen plus, hydrogen plus. So this becomes H2SO4, while this becomes H2SO3, and this becomes H2S. And this is that formula earlier that I was doing, H2S. Which weird, it has 2 different Wikipedia pages. Oh, because the other one was a sodium. So the preferred name of that chemical is not treating it as an acid, but treating it as an ionic compound. And we get hydrogen sulfide. But other names of it do include hydrosulfuric acid is an acceptable name for it. This I don't test on it, but iron 3 oxide. What is the formula for iron 3 oxide? I do test that, but it's an alternative name for this. What is the formula for iron 3 oxide? So this would be iron 3 plus. Oxygen would be 2 negative. So crisscross, the 2 comes down here, 3 comes over here. This is also known as ferric oxide, whereas iron 2 oxide would be iron 2 plus, oxygen 2 negative, that's a 1-to-1, so FeO. This is known as ferrous oxide. The higher charge gets the ike, Ike, where the OUS is the lower charge ending. I don't teach that because it's not commonly used. But if you ever Google iron 3 oxide, you'll see ferric a lot. I'm trying to get... Alright, here's a good example. Which of these contains an iron 2 ion? Yes. So we know chlorine is negative. So 3 times negative gets this whole thing. That's 3 negative, which means this must be positive 3. We just did this one. You can do the inverse of cross-cross. So we know that we're going to have an iron oxide here and an oxygen ion here. So 2 is going to come up here, while 3 comes up here. Here we have this one. So that's negative 8 here. Phosphorus is in group 5, so that's plus 5. So this is going to get 3 negative charge. So if we do the opposite of crossing, this has a 3 negative charge. So we have 3 iron. The 3 is going to come up here. And the 2 on this has to come up here to this one. So this must have a 2 plus charge. Because the 2 down here would go back when you cross. And same thing here. We have iron 2, SO4, 3. So 3 is going to come up here for this charge. And the SO4 is going to come up here for this one, so that's a 2 negative. So this one is iron 3 also. We'll review some more tomorrow and test Wednesday. We have a half a day Friday, don't we?
I think. Yeah, because winter break, Valentine's weekend. Oh, we have winter break next week? Mm-hmm. Yeah, we have one school next week.
Or would y'all rather have test tomorrow?
I think probably Wednesday because Darby needs to have Sunday if she's here tomorrow.
Well, she can watch the video. But the reason why it's games tomorrow? Which means it's unlikely I'll be studying tomorrow night afternoon, right?
Actually, 100% unlikely. So honestly, probably tomorrow will be better for me.
Let's see if there's anything I haven't really covered. I mean, that's it. I gave over the definitions. I asked some questions. Is this molecular covalent? Is this network covalent? As possible choices. Here's a deal. When I ever ask you something, are units not over? You can immediately rule those out. Like the possible answer choices: is this an ionic bond, molecular covalent, network covalent, or metallic? We only covered metallic and ionic this section. I really need to have the test Wednesday because there's some more things. I'll send a notification out. Oh, because reviewing which is ionic and which is not. The 1.7. Yeah, we're gonna have it Wednesday.